My name is Ethan Kerb, and I'll be introducing our project titled the Analyst Copilot. A little bit about our sponsor. Our sponsor is the 16th Air Force, which is the branch of the Air Force that is responsible for defending the Department of Defense's network against nation-state hackers. This project actually began when we met with our client at Lackland, which is the Air Force Base in San Antonio, to meet and discuss the end goals for the project and scope. Some notable members of our sponsor group include a three-star general and a lieutenant colonel, among others. So before I talk about the solution in our project, it helps to understand a very important term, which is a SIM. A SIM is essentially a real-time alert system that tells you when something unusual happens in a network. And the easiest way to picture it is like imagine you're supposed to defend a city by analyzing and running traffic control. So think about College Station, where you have cars that are constantly flowing in and out of the city. They're flowing on University Drive, Wellborn, Texas Avenue, and all the other major roads. And now imagine that you're at your desk and you have a computer that allows you or that alerts you every single time a driver in the city breaks a traffic law. And it'll give you a notification like red SUV ran a red light on University Drive at 2:17 p.m. And that's technically good information, but it's not enough to act on. You wouldn't start shutting down intersections or send out a police response every time someone ran a red light. Most of the time, it's just random noise. But here's the problem. What if I told you that the driver of that red SUV, is the same person who robbed a bank 2 weeks ago and they're about to rob another bank? Because the original alert that you got gave you no context, you have no idea who's driving the car, what direction they're heading, what roads to close, and by the time you piece all of that information together, the driver has escaped. And that missing context is exactly the problem that cyber analysts have when they're dealing with real world SIMs today. A SIM will give them a bare alert, which we call an event package or a log, and they're expected to turn that into a full understanding of what happened, who's behind it, and what to do right now to stop it. And so when the stakes are high and you're defending a DoD information network, that gap is very critical. And our tool is designed to help fill in those missing pieces autonomously. And so now that we've discussed and defined what a SIM alert is and the problems with them let's discuss the real problem that our sponsor brought when we met them at the Air Force Base. And basically at the core, the problem is that cyber analysts today face millions of these contextless alerts every single day, and there's no tool that turns a raw alert into a clear, actionable defense narrative and properly defines what a false positive is and what a real threat is. And so when our sponsor asked for help automating the analysis, the request wasn't a list of features, it was an open-ended question to see what we could build to address this specific issue. And so we designed our project to focus on the highest cost bottleneck, which is effectively what I just described, which is how do we take an alert package and quickly move it to a response as reliably as possible before the adversary moves again. And so the approach that we took was firstly, we didn't define this problem as just an AI problem. We treated it like it was a workflow problem. So we asked the sponsor, this guiding question, what does an analyst actually need to understand an incident quickly? And it's from that we built a system around three core ingredients. First, the security logs themselves, which we call the alert package. Second, were threat intelligence frameworks, specifically MITRE ATT&CK and MISP. If you don't know what these frameworks are, I'll explain them. You can think of MISP like an ID book. So going back to the red SUV analogy, it's like a giant database where you can look up the red SUV's license plate, color, make, model, and you can see if this specific vehicle is linked to any other crime incidents in the past, which is very helpful for the scenario where the red SUV driver is a bank robber and just committed a crime recently. MITRE ATT&CK, on the other hand, is like a playbook of how bad drivers typically behave. So it doesn't just say, a bad driver runs a red light. It lists patterns that bad drivers will follow when they're serious offenders. So a bad driver is someone who's escaping from a bank robbery. Not only do they run red lights, they speed, they loop back through neighborhoods, they avoid maiden roads, they cut corners, make illegal turns. and things like that. And so when you have all these patterns, you start to recognize the behavior of running a red light as not just an isolated incident, but as a part of a larger attack chain. And so now you have all of these logs that describe, you have all these frameworks and you've consulted them and you understand now that your red SUV that's running a red light, it's not only running a red light, but they're weaving in and out of traffic, they're speeding, and they're driven by a known criminal. And that's where we have the third ingredient in our pipeline, and that's an AI model that's trained to specifically correlate that domain knowledge and turn it into a structured, defensible report with action items and next steps. So now you have a full story about this red SUV. It's not just some random car breaking random rules. It's a car that was identified as moving dangerously, following a specific pattern, and driven by a known criminal. And this process of piecing together a story right now is manual and it takes hours. And our whole system is designed to automate the creation of that story as quickly as possible. And that's why the core of this project is not the LLM, it's the automation of a workflow that is currently manual.
Hello, my name is Kyle Easton, and I'm the Chief Information Security Officer for our project. And as Ethan just mentioned, the main problem we are tackling here for the cyber analysts at the 16th Air Force is that they face a large volume of logs and alerts that are output by existing SIM solutions. And talking about this existing solution and what are the limitations of today's tools. Well, today's tools, they will detect, they will give those alerts, but they do not add a whole lot of that background information that we were talking about. And these tools also produce a huge volume of alerts. Our tool that we have developed aims to tackle those problems by adding context through the MISP integration, which helps us filter out benign alerts and also provides actionable insight based on existing frameworks like the MITRE ATT&CK framework. So how exactly do we go about that? So we begin with log normalization, and that comes directly from the SIM. We ingest the output logs and alerts package generated by a SIM, and then we're able to extract certain indicators of compromise from those logs, and we send them to MISP in order to gain that insight of current cyber threat intelligence data. And from that, we fuse together the two pieces, the SIM output as well as the MISP enrichment, and we plug it into a RAG LLM that is trained on the MITRE ATT&CK framework in order to reduce hallucinations and improve the quality of the output, giving it actionable insight from actual TTPs from the MITRE ATT&CK framework. And then we use all of this to create a report. So our product has a dashboard where we are able to see actionable reports generated by our LLM using all of that data that we ingested and enriched into a nice front-end dashboard. So to recap, we just get our input from the SIM, and our goal is to change that into an output of a actionable cyber threat report containing a clear summary, key findings of what is going on, as well as suspected possible behaviors and techniques from the MITRE ATT&CK framework. And it is also capable of identifying potential adversaries from advanced persistent threats, as well as the report provides next steps that the cyber analyst may be able to take based off of what is seen in the alert from the SIM. And our front end all displays this quite nicely, as you will see in our demo.
Howdy, my name is Nick, and I'll be talking about the ethical considerations as well as showing a quick demo of our project. So one of the ethical considerations we were told to address was data exfiltration. The Air Force works with a lot of sensitive data, and it's not trustworthy to send this data to an open source or an open cloud large language model like ChatGPT, Claude, or Gemini. So we decided to make our large language model local and hosted on our personal machines. This allows the processing to be done in a secure offline system, so you don't run the risk of your data being stored somewhere you don't know or intercepted while traversing through the internet. Also, our large language model is built off of a RAG architecture. RAG stands for Retrieval Augmented Generation, and this allows the large language model to become more precise and accurate on its responses, help reducing bias as well as hallucinations. The RAG architecture basically defines a context knowledge base, a specific context knowledge base, in our example being MITRE and MISP data. This allows it to give more accurate responses. And finally, doing lots of testing and having strict output constraints. This streamlines our responses and lowers the amount of varied responses. So in machine learning terms, lowering the temperature. So on to the demo. So right here is the front end of our demo where you upload a log file. So for example, this log file you see here, this would be an example of what a sim might see. So if you're an analyst reading all of this alerts, it's really hard to digest. And so this is where our project comes in. So analyzing this will take a while, so we'll skip forward. So after processing this, the LLM intelligently gives you a summary as well as findings about the whole alert, as well as giving some TTPs and APTs that are potentially within the alert. This data is in the MITRE ATT&CK structure, and so this can give you an analyst. This can give an analyst a brief overview as well as in-depth about what's really going on in their systems. Thank you.